Hello and welcome back. In this video, we'll look at some while loop programming patterns. And we'll also take a brief look at the break statement and tell you that in 121 it's something you should stay away from. So, often when we're programming, we want to continually prompt the user and maybe process their command continually until they type quit, or prompt the user for a command until they type a legal command. We can't do anything with their input if it's not a command that we know about. So this turns out to be slightly problematic when using while loops, and here's why. If we take a flowchart view of this process, it's really quite easy to draw out. Our program comes down, it reads some data from the user, asks whether that data matches the terminating condition, and if it does, we'll terminate. We don't need to process any further. And if it does not reach the terminating condition, well, we'll process the line or issue an error message and come back to the start, and then prompt them again, read the input, and determine whether it meets the terminating condition. So in a flowchart view, this makes a lot of sense. But in a while loop, the difficulty arises because a while loop, the test for termination occurs at the very beginning of the loop. Remember, the syntax is while condition colon. Okay, so here our loop is coming back to something before the start of the loop. So how do we convert this into a while loop? Well, it turns out we've got three general strategies for doing that. The first is called the 1.5 loop solution. And the reason for that is, well, we've got a preparatory statement at the beginning. So we have a preparatory statement that is not inside the loop, that's then repeated inside the loop. So for the very first time, we have a request to get some data from the user before the loop. That makes the test for termination then legal because we have a piece of data to work on. We then process the item and get another item, and when we then come back to the start of the while loop and say, does the termination condition apply now? Okay. So compared to the flowchart, we've got one of the steps being repeated. This step, to read the next line, is being repeated both before the loop and at the end of the loop. And when we come back, we're coming back to the test for termination. Okay, so this step is being repeated, it's being executed before the loop begins, and it's being executed at the end of the content of the loop. A second solution uses a Boolean flag. So we'll make an assumption before we start the loop that we're not finished. So is done equals false. Have we finished? No, we haven't. And then our terminating condition is, have we finished yet? So we'll say while not is done, so while the truth of is done is false, we'll retrieve an item, we'll process the item, and if we're finished, we'll have a test for the finishing condition, and if we are finished, we'll have is done is assigned the value true. So if the item does not need action, well, in that case, we can assign is done is true. Then, when we come back to the start of the while loop, we'll know that not is done is false, and we'll terminate the loop. The third solution is to use break, and this is one that we wouldn't recommend, and we'll briefly tell you about the break statement at the end of this video. So here we have an ugly sort of something that looks like an infinite loop. While true, that just means while forever. Get an item. If the item needs action, well, process it. Otherwise, break. And break is a mechanism just to snap out of a loop and terminate that loop immediately. But it's very easy to misunderstand programs when you're using break, so we advise you not to use it. So here's an example of looping until quit. Under idiom 1, that's the loop and a half example, we have the prompt, we initialize a prompt, which is enter command or Q to quit, and we then ask the user for that data. So we assign to command whatever the user types, and we're prompting them with a prompt and turning the string that they type to lowercase. Okay, so you'll see that that command to input data from the user is repeated both before the loop begins and at the end of the content of the loop. 1.5 loop example. So while the command is not equal to Q, we'll process the data, and then eventually the user will type to the prompt Q, and that's the new value for command. we'll come back to the start of the loop and it'll say, well, the command is not equal to Q. Well, if the user's just typed Q, that's our terminating condition satisfied. Using our second example with the Boolean variable, we'll start off by assuming that we're not quitting, so is quitting is false. We initialize our prompt, but this time there's only one place where we actually input the data from the user. There's no actual input prior to beginning the loop. So while not is quitting, while our Boolean value for is quitting is false, we'll prompt the user, we'll process their data. Okay? And somewhere in here there needs to be something that says, oh, there it is, if command equals Q, well then is quitting is now true. Okay, so we've set the terminating condition there on the condition that the user types Q. Here's another example. Imagine we're writing a game using a standard pack of cards. So we've got 4 possible suits. We've got spades, hearts, diamonds, or clubs, all in lowercase. This is the prompt that we'll send to the user. This is the 1.5 loop example. The response is the result of inputting, showing the user the prompt, and turning it all into lowercase. While response not in, so while response is not one of spades, hearts, diamonds, or clubs, we're going to tell the user, actually that's an invalid suit, try again, and we'll then input again from the user. Okay, so 1.5 loops, the input occurs before the loop and at the end of the loop. So here we go, I can, what suit? I'll type Barney. So that's not a valid suit, so it's actually, it tells me not valid, invalid suit, try again. Mary, not a valid suit, and then I'll do hearts. And of course, because we're invoking the string's lower function on whatever the user types, that's converting whatever the user types to lowercase. So this will be in spades, hearts, diamonds, and clubs because lowercase hearts is in that list. So there we go. We managed to satisfy our terminating condition. Alternatively, using the Boolean variable example, there's our prompt all ready to be used. We assume that it's not valid. We then have while not is valid, so while the user's entry is not valid. We'll prompt the user and input some data. If the response is in the set of legal values, we'll set is valid to true. That's our terminating condition satisfied. Otherwise, we'll print invalid suit, try again. So, and again, this time I'll just type clubs. Okay, and so it terminated straight away. The choice of which of these two solutions you prefer, well, it's really down to your individual stylistic choice. I guess, in this case, I probably prefer the briefer one, idiom 1 for this particular example, but honestly, if you prefer idiom 2, that's absolutely fine. Programming style, well, you'll learn a lot more about that later. Okay, just to finish off quickly today, you can break out of any loop by using a break statement that forces immediate exit from the loop and goes straight to the first statement after the loop. It's really easy to program this way, but it's also very easy to confuse yourself and misunderstand the execution of the program, particularly because the terminating condition for the loop is no longer explicit. Rather than looking in one place where the loop is defined while exit condition is defined, you have to look through a whole series of statements, and that can be confusing and it encourages misunderstanding. So it's much harder to reason about the program, prove it correct, and understand it. It also encourages lazy style of programming where the conditions for termination just become a bit more amorphous, if you like. It's really hard to tell exactly what causes the program the loop to terminate. And that's anything that's hard to understand is hard to maintain. Very finally, converting between a for and a while loop. Any for loop can be rewritten as a while loop, and it's a really simple translation, or relatively simple translation. For element in item list, do something with element, can be rewritten using an index into the structure. So I equals 0, while I is less than the item list. Element equals item list index by I. Do something with element, and then increment your counter. Okay, so it's an easy translation between any for loop and a while loop. But for loops are naturally simple for lists of for any list or sequence data type. Okay, go and practice with your while loops. Thanks.